Hi, hello, this is Mr. S. Today we are gonna learn about the Java programming core concepts, the four pillars of the OOP and exception handling. So let's start. Firstly, we'll start with what is meant by Java. As you know, Java is a programming language. Firstly, the Java is a high-level programming language which is of the robust, object-oriented, and designed to have as few implementation dependencies as possible. The key features of the Java are platform independent, object oriented, robust and secure. Platform independent, that means once we can write the code and run anywhere, that means of in any type of the compiler or interpreter. Object oriented, that means the models of the real world entities for a modular code. Next, there comes the robust and secure. That means automatic memory management, garbage collection, and built-in security. Garbage collection can be said as the wastage memory or the waste memory. When it comes to the platform independence, we can say as WRI, that means write once and run anywhere. Next, we are coming to the main pillars of the Java. See, in any of the programming languages, that might be a high level or low level, there will be the pillars. Without the pillars, see, for if you take the a house construction, without the pillars, a house cannot be constructed or it cannot be built. The pillars are the main things which keeps a house or any programming language or anything stable. The object-oriented programming (OOP) in Java revolves around four fundamental concepts that are the pillars, which make the code reusable, flexible, and scalable. The four main pillars of the Java are encapsulation, data abstraction, inheritance, and polymorphism. Pillar number one, the encapsulation. It hides or hiding the internal state and requiring all interaction to be performed through an object's method. Let's start. What is meant by an encapsulation? It refers to encapsulation is the mechanism of wrapping or warping of data and code acting on the data together as a unit. Firstly, the data considered as a variable, and second, when it comes to the acting on the data, that means of the methods. It shields the data from being accessed directly from outside, promoting strict data types or strict data hiding. The typing or types access modifiers are there are four types of access modifiers. They are the private, default, protected, and public. First, the private. It can be accessible only within the class. Default. It can be accessible within the same package. Protected. It can be accessible within the package in the child classes. Public. It can be accessed or accessible from everywhere. So there's a difference between the default and protected is of default can be accessed within the same package, but when it comes to the protected, it can be accessed within the package and classes. And the public can be accessed from everywhere. Next, there comes the encapsulating implementation. See, the syntax and the rules are there should be the declaration and the variables of a class as a private, that provides the public setter and getter methods to modify and view the variable's values. This provides a control over the data, allowing you to make fields read only or write only. Here's an example program given once you can go through it, which can be very helpful for you in the future. Next, there comes the pillar number two, data abstraction. It is showing only essential attributes and hiding unnecessary implementation details. Let's start. Types of data abstraction. There are two types: abstract classes and interfaces. When it comes to the abstract classes, the abstract keyword is to be declared. It is a mandatory one. Can have both abstract and concrete methods. Abstract classes provides 0 to 100% abstraction, which cannot be initiated directly. When it comes to the interfaces, the interface keyword must be declared. It is mandatory. It provides 100% abstraction prior to the Java 8 version. All methods are implicitly public and abstract. Class implements an interface. Remember and note. When it comes to the abstract classes, abstract keyword is to be declared. When it comes to the interfaces, the interface keyword is to be declared. Next, there comes the abstract classes examples. You can see there's an abstract class example and interface class example. Go through that and don't forget. Okay, it's very useful. Next, there comes pillar number three, inheritance. It means creating new classes from the already existing ones to promote the code reusability. Let's start. So the inheritance means inheritance. It is a mechanism where in a new class acquires all the properties and behaviors of an existing parent class. The parent class can also be said as a base class. The child class can also be said as the derived class. It establishes an IS is a relationship, parent-child relationship. The types of inheritance are given below. The Java supports the following types of inheritance via the classes. Single inheritance, only there will be one child and one parent. When it comes to multi-level, there will be a chain of inheritances. When it comes to the hierarchical level, there will be multiple children and there will be only one parent. Note that multiple inheritance is supported only through interfaces, not the classes. Single inheritance, the definition syntax are there. In single inheritance, one subclass inherits from exactly one superclass. It is the simplest and most common form of the inheritance. The syntax is given below. Go through that once. The example program is also given. Check it. Next, there comes the multi-level inheritance. In the multi-level inheritance, a derived class acts as a base class for another derived class, creating a continuous chain of inheritance. The syntax and example programs are given below and beside. Once go through that, be careful. Next, there comes the hierarchical inheritance. In hierarchical inheritance, two or more separate subclasses inherit from a single common superclass. Go through the syntax and example program. Next, there comes the fourth pillar, that is the polymorphism. That means there is only one name, many forms. It is a Greek word. Poly means many. Polymorphism is a Greek word. Poly means many and morphism means forms. That means the ability to take or change in many forms. It is performing a single action in different ways. Let's start. What is polymorphism? As we said before, the word polymorphism is derived from two Greek words, the poly, many, and the morphs means forms. In Java, it is the ability of an object or the method to take on many forms, allowing us to perform a single action in different ways. There are types of polymorphism. They are compile time and runtime. Compile time polymorphism, which is achieved through method overloading. The method to be invoked is determined at compile time or runtime. It is achieved through method overriding. The method to be invoked is determined at runtime based on the object type. See, the types of polymorphism are not said as a compile time and runtime. It is said as a compile time is said as the method overloading, and the runtime is said as the method overriding. Okay. Next, we are starting to the compile time. That means the overloading. It means method overloading occurs when a class has multiple methods with the exact same name but different parameters. The parameters can be the numbers, types, or the sequences. The syntax and the example program is given. Go through that once. Next, there comes the overriding. Method overriding occurs when a subclass provides a specific implementation of a method that is already provided by its parent class. Syntax and example program is given below. Check it out. Next, there comes the exception handling. It means ensuring normal execution flow by managing runtime errors elegantly. What is exception handling? It is a powerful mechanism to handle runtime errors so that the normal flow of the application can be maintained without the crash. There are types of exceptions. So let's start. Checked exceptions. It means exceptions checked at compile time. Example, IO exception, SQL exception. It must be declared or caught. Unchecked exceptions. That means exceptions checked at runtime. Example, assembly exception, null pointer exception. The errors are irrecoverable systems issues. Examples are the out of memory error. Next, there comes the exception handling implementation. There are the core key concepts, the syntax also, and the example program also given there. The core keywords are the try, which specifies a block where an exception code is placed. Catch, which is used to handle the exception thrown by a try block. Finally, it executes the important code regardless of whether an exception is handled or not. Throw or throws. It is used to explicitly throw or declare exceptions in method signature. Okay, thank you. That's all for today. Bye.